In our next question of exercise 12.05, we've got a coin and a die which are tossed together. So this two-step experiment requires these two things to give us different outcomes and a pair of outcomes actually. So in one case, in these two rows, we've got the results of the coins, which are heads and tails, whereas over here, okay, these columns, they represent the results of a die, okay, which resembles 1 through to 6. And so when we actually populate all the different pairs of outcomes, we can start by writing the letter first. Okay, so we'll toss a head, and then we'll toss, we'll get a 1 from the die, okay, and then we'll toss a head again, and then a 2 from the die, head again, then 3 from the die, and so forth. So you know that the results go from H1 to H6. Then what we can do is we can toss the tails and also roll a 1. Okay, we can toss tails again, roll a 2, and so forth, all the way to T6. Now find the probability of tossing a head and a 4. So if we want a head and a 4, that resembles this one, okay, H4. And altogether, you've got 2 rows here and 6 columns. So 2 times 6 is 12. That gives you the total different number of pairs. So we've got basically 1 out of 12 for part A. And for part 2, a tail and even number. Okay, so if we want a tail first, that will be T2 as our first pair with the lowest even number, then T4, then T6. So there's 3 out of 12 altogether, and that gives you 1/4 when we divide the top and bottom by 3. Then for part 3, a tail and a number less than 5. So if you want a tail and a number less than 5, then you're going to have to look at the row with tails only. So that's T1, T2, T3, and then T4. So there are 4 out of 12, which the top and bottom can divide by 4 to give you a third, right? Moving on. Question 4. 2 dice are rolled and the sum of the numbers is calculated. Copy and complete this table to show all possible outcomes. So it'd be a good idea to copy all this down, okay, in your grid books. And what we're going to do is we're going to add all the values that we get from our first die here with the value that we get from the second die here. So let's look at the intersection between these two numbers. That's over here. 1 plus 1 is going to be 2. And then 1 plus 2 here is going to become 3. And we do the same thing to the next one. So 1 plus 3 is 4, then 5, then 6, then 7. Now if we add 1 and 2 here, we get 3. If we add 2 and 2, we get 4. 3 and 2, we get 5. And then you know that the numbers just keep going up by 1. So that'll be 6, 7, 8, right? Then if we add 1 plus 3 here, we get 4. And 3 plus 2, we get 5. And then what I want you to notice is a pattern here. If you look at these numbers diagonally, they're exactly the same. So these are all 3s, these are all 4s. So if you look at the next diagonal, these should all be 5s. Then I'm just going to complete the next diagonal, which are 6s, then 7s, then 8s, then 9s, then 10s, and 11s, then 12. Okay, that's the quickest way I would use to fill up the table. Then for part B, find the probability of rolling a sum of 3. So how many 3s do we have here? We've got basically 2 of them, right? Okay, but in this case, if we roll 2 of them, what's it out of though? We've got 6 that we can get from the first die and 6 we can get from the second die. So 6 times 6 is 36. We have 36 outcomes that we can get. And the ones we want is just the number 3. So there's 2 of them. So that will be 1 out of 18. Then for part 2, if we want the number 7, there's 1, 2, 3, 4, 5, 6 of them out of 36, which gives us Oops, not 1 out of 18. It's 1 out of 6 if we divide the top and bottom by 6. Okay. Part 3, if we want at least 6 means 6 or above. So if we count the numbers that are 6 or above in this case, got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There are 26 numbers which are 6 and above. And if we now get the answer as 26 over 36 and simplify that answer, we get 13 out of 18 by dividing by 2. Let's count how many are less than 10. So numbers less than 10 would be all of these ones here. Okay, so anything from 2 to 9. I think the easy way to do this is not to actually count these numbers individually. I would get the total number of numbers here, or outcomes, which is 36, subtracted by the ones which are 10 and above. So we've got 1, 2, 3, 4, 5, 6 numbers that are 10 or above, okay? But in total, there are 36 of them, and we want the ones that are not circled. So if we do 36 minus 6, that gives us 30. That's what we want. So with 30 out of 36, if we divide the top and bottom by 6, we'll get 5 out of 6. Okay? Then let's calculate the sum, a probability of a sum that's even. So that's all the 2s, 4s, 6s, and 8s and 10s. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, oh, and 18, sorry. There's a 12 there, that's an even number as well. So that's 18 out of 36, which is magically half. So half the numbers in this lot here are even, and half of them are odd. Okay, last part. Whoops, read it wrong. That should be VI. Between 3 and 7. So if it says between 3 and 7, okay, what we've actually got to find out is the number of numbers which are 4 to 6. So if we calculate what that is, okay, let's calculate that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers out of 36, which we can divide the top and bottom by 12 to give you 1/3. And I'm just reminding you that when it says between two numbers, you don't include these two numbers. You actually include the one above this and below this. So that's actually inclusive of 4 and 6 as our lowest and maximum numbers.